Now I'm going to introduce you to the gravimetric analysis. Gravimetric analysis is a technique to determine the amount of an analyte in a sample by converting the analyte into some product where mass of the product can be measured. Here, I include the diagram of how gravimetric analysis looks like. The procedures of gravimetric analysis include preliminary treatment, precipitation of precipitates, digestion, filtration and washing, drying or igniting, weighing, and finally the calculation of the amount of element or radical to be determined. Next, when doing gravimetric analysis, there are some requirements you need to take in consideration. First, identify the insoluble form of an analyte. Next, separate the analyte from any constituents that may interfere. Wash the precipitate free of impurities and co-precipitants. And finally, convert the precipitate into a stable weighing form. Here, I include some applications of gravimetric analysis. Gravimetric analysis can be used to determine inorganic anions such as chlorine and cations such as ferrum. Gravimetric analysis also can determine neutral species in samples such as oxygen and carbon dioxide. Gravimetric analysis can also be used to determine organic samples such as lactose in milk, cholesterol in cereal, and acid amino in food.
Hi, now I will explain about the theory of gravimetric analysis. The technique in which the amount of an analyte the ion being analyzed in a sample can be determined by converting the analyte to some product, change of chemical states of the analyte, where mass of product can be measured. Based on the measurement of mass, use analytical balance instrument that yield highly accurate and precise data, most accurate method of chemical analysis. So there is two types of method. The first one is precipitation method. The analyte is converted to a sparingly soluble precipitate that is filtered and washed free from impurities, which convert to a stable product and non-composition by suitable heat treatment. Then the product is weighed. The second method is volatilization method. The analyte or its decomposition product are volatilized at suitable temperature. The volatile product is then collected and weighed, or alternatively, the weight of the product is determined indirectly from the weight loss of the sample.
Next, we move to preliminary treatment. This is the procedure to prepare solution that contains sample to eliminate interfering materials. The purpose of this procedure is to adjustment the solution condition before precipitation to maintain low solubility of precipitate and obtain a suitable precipitate for filtration. First, we need to consider a few factors before prepare the solution, which is adjusting the sample solution to necessary pH, temperature, volume of solution during precipitation, the presence and the concentration of other constituents, and lastly, concentration. Next step is precipitation, which is a process that occurs when a portion of dissolved chemical leaves the solution from solid. Granular precipitate is one of the example precipitate that very desirable because it presents a relatively small surface area and less liable to contamination. It is also easier to filter granular than gelatinous precipitate. On this step, the particle make up of larger particle and have low solubility because large particle is easy to filter and can minimize contamination from impurities. There are two types of precipitate, which is crystalline and colloidal suspension. The particle size is related to a single property of system that called relative supersaturation. This particle size can be calculated by using the equation Q minus S divide S. When the value of Rs is large, the precipitate is colloidal, and when the value of Rs is small, the precipitate up is crystalline. Moreover, there is four properties of good precipitate, which is consists of large crystal, sufficiently insoluble, stable, which is unreactive with constituent atmosphere, and lastly, non-composition after it is dry. There are six ways to form large particle precipitate. First, precipitate from dilute solution, then add precipitating reagent slowly and stir effectively. Next, precipitate from hot solution and precipitate at low pH, lowering the temperature slowly, and lastly add organic solvent that can mix with water. The precipitate resulted when analyte react with precipitant becomes supersaturation. These precipitants are chosen from the ability to be selective to form high insoluble precipitate and reproducible stoichiometry. There are two types of precipitant, which is organic and inorganic. These are the difference between organic precipitate and inorganic precipitate. Organic precipitant form slightly soluble salts, while inorganic precipitant form metal precipitate. Most organic precipitant are not selective, while inorganic precipitant is fairly selective. Two examples of organic precipitant is silver nitrate and barium chloride. The advantages of inorganic precipitant is it forms chelate compound with cation that very insoluble in water. Other than that, the small amount of metal yield is large weight of precipitate, and lastly is Precipitate that are obtained is bulky and coarse and also easy to handle. Next is nucleation mechanism, which is an individual's atom coagulates to form nuclei by adding dust particle, crash on vessel, and seed crystal. There are two reactions, which is spontaneous and induced, that is required seed to react. The small particle will become nucleation, and lastly become colloid particle. There are two ways for cooling, which is rapid cooling and slow cooling. There are many nucleation sites at rapid cooling, while on slow cooling there is yet of a few sites on crystal. When the nucleation increases, it leads to more number of smaller size colloid. That form of crystal leads to absorb the impurities. Third step is digestion, which is the small particles are not retained by the ordinary filter. Digestion process is the phenomenon when small precipitate presents in the solution, which is it was precipitate is allowed to grow to form larger crystal when heated. This process improves the purity and filterability of the precipitate. This can be done at elevated temperature to speed the process of agglomeration and coagulation. Very small particle with large specific surface area, higher surface energy and higher solubility compared to larger colloidal particle. Small particles tend to dissolve and precipitate on the surface of the larger crystal. Agglomerated using coagulant give a filterable amorphous mass that will settle out of the solution. It also can be often coagulated by heating, string and adding electrolyte.
Next is filtration and washing. After precipitation has taken place, the precipitate must be separated from the supernatant solution, which normally contains excess common iron, and other constituent of the sample by filtration technique. Filtration using filter paper is used to collect all the precipitate form. So there is three grades of filter paper. The first one is filter paper number 42 for fine precipitates. The second one is filter paper grade number 41 for coarse or gelatinous precipitates. And the last one is filter paper grade number 14 for medium sized or crystalline precipitates. Washing is required because precipitating reagent is usually added in excess. The precipitate form is usually not 100% insoluble. Therefore, great care is taken during washing and do not wash the precipitate too long. Many precipitates cannot be washed with pure water because peptidization occurs. So the best way to solve the problem is to wash the precipitate a few times, not to wash once with total same volume of washing solutions. So that there is five ideal washing liquids. The first one is no solvent action on precipitate. The second one is dissolved impurities easily evaporates at drying temperature of precipitate, contains no substance that will interfere with subsequent determinations of the filtrate. And the last one is, in general, pure water is ideally used. So next is drying. After filtering, the gravimetric precipitate is heated until its weight becomes constant. Drying usually be done by heating at 110 Celsius to 120 Celsius for 1 to 2 hours. Heating removes the solvent, absorbs electrolytes, and any volatile species that is carried down with the precipitate. Some precipitates must be ignited to decompose the solid and form a compound of stable and non-composition. This new compound is often called the wet-heat form. So next is weighing. Weighing is weighed using a sensitive analytical balance. So there is two methods to calculate the amount of analyte in the weighing form. The first one is chemical factor and the second one is gravimetric factor.
Now, I will explain the methods to calculate the amount of analyte in the weighing form. So there are two ways that we can use, which is the first one is chemical factors and the second one is gravimetric factor. For this slide, I will explain the methods by using chemical factors. So there is a general formula on how to calculate X, which is weight of analyte. Firstly, we find X, weight of analyte, by dividing the molecular weight of the precipitate with the number of atomic weight precipitate that multiply by atomic weight of the element. And the answer we divided with W, which is the weight of precipitate. Next, after we get the value of X, we can find the percentage weight of the weight of an analyte in sample by dividing X with W, which is the weight of given sample, and multiply it by 100. So finally, we can get the percentage weight of the weight of analyte. So next, for this slide, I will explain how to use gravimetric factors method to calculate the amount of analyte in the weighing form. To get the weight of analyte, we must multiply gravimetric factor with weight of weighing form. But how to find the gravimetric factor? So there is a formula to calculate gravimetric factor. Make sure to identify first the analyte and precipitate. Now, here are the example of calculation to determine iron in sample by using chemical factors method. Let's read the question first. 2 grams of an iron compound after suitable treatment yield 0.2565 grams of ferric oxide. Calculate the percentage of iron in the compound. Firstly, identify the analyte and precipitate in this question. The precipitate is ferric oxide and the analyte is iron. Then just calculate it by using formula of chemical factors that I had explained in previous slide. This is calculation of determination of iron by using gravimetric factors. We also get the same percentage of weight over weight of iron, which are 8.98%.
In conclusion, we got knowledge about the theory of gravimetric analysis of ion. We also learned how to convert ion to precipitate form by following the methodology of gravimetric analysis. Other than that, we also learned how to convert the ion to precipitate form by following the methodology of gravimetric analysis. Throughout the process, potential sources of error such as incomplete precipitation, loss of precipitation during filtration, and contamination are carefully managed. Drying and ignition will be used to decompose the solid to form a stable non-composition before weighing the dry and calculate the mass of analytical by using chemical factor and gravimetry factor.